Hello, I'm Seema from Alobasics. I welcome you all for the next video on wave optics. In this video of wave optics, we'll study nature of light. Nature of light. What is nature of light? Is it particle or a wave? Various concepts came forward in different centuries depending on the phenomena related to light were known at that time. Initially, it was considered that light is in the form of particle. And related to this concept, first theory was put forward by Newton, known as Newton's corpuscular theory. Then came the wave nature of light, which was suggested by Huygens, known as Huygens wave theory. Both these theories were proposed within a gap of few years. After that, in coming centuries, new phenomena related to light were invented. Some of them are supporting wave nature, whereas some are explained on the basis of particle nature of light. At last, dual nature of light was accepted. All these theories related to nature of light will discuss one by one. Regarding nature of light, first widely accepted theory was Newton's corpuscular theory, which supports particle nature of light. In fact, in 1636, R. Descartes proposed particle nature of light. He has proposed particle nature of light before Newton, but he could not give evidences to support his theory. And in 1665, Newton put forward his theory regarding nature of light. It is purely based on the phenomena of light known at that time, such as rectilinear propagation of light, reflection, refraction of light, different colors of light, etc., etc. What was his considerations or assumptions regarding this particle nature? That we'll see. And Newton's assumptions. First assumption is that light is in the form of tiny, hard, massless, elastic particles known as corpuscles. Now you might have understood why it is known as Newton's corpuscular nature or why it is known as Newton's corpuscular theory. So he has considered light is in the form of very, very small particles known as corpuscles. Now second thing he has assumed, based on the rectilinear propagation of light, or light travels in a straight line. This you have studied at your school level. This phenomena was known at that time, and he explained this phenomena on his consideration, that is the particle nature of light, that he has said that the light emitted by the source is travel in a straight line with high speed. As it is particle, it can travel in straight line. That was his assumption. So he has explained rectilinear propagation of light very easily with particle nature. Now, the next thing he has considered that when that light strikes the reflecting surface, it undergoes elastic collision, and as a result of it follows laws of reflection. Now all of you have studied laws of reflection, refraction at your school level. So you are familiar with that, and we know that when light travels in a medium and when it strikes the reflecting surface, then it gets back into the same medium. We call it as reflection. And he explained this phenomena of reflection or all the laws of reflection with the consideration that these corpuscles undergo elastic collision, and due to that reflection is possible. So he has explained reflection also. Now what about refraction? Regarding refraction, he said that change in direction during refraction is due to difference in the attractive force between corpuscles and particle of the medium. Now when light is traveling from one medium to another medium, we know that it changes its direction. And here, refraction phenomena is possible due to difference in attractive forces between corpuscles and particle. That explanation he has given, and he explained refraction phenomena also. Then comes the next point, which he has said that denser medium exerts larger force of attraction on corpuscles to accelerate them. That means speed of light in denser medium is more than in rarer medium. Now see here, what Newton has considered? Newton has considered that speed of light in denser medium is more than in rarer medium. This was Newton's consideration. At that time, actually, it was not known whether speed of light is more in denser medium or rarer medium. But this he has given explanation for this on the basis of force of attraction. Now, one more phenomena regarding light was known that time, that light has different colors. Now, what he has explained for that? He said that different colors of light are due to different sizes of corpuscles. Newton's assumption was that corpuscles are not of same size. Their sizes are different. And as their sizes are different, due to their different sizes, we see different colors of light. So, at that time, the known phenomena were rectilinear propagation, which he has explained, reflection he has explained, refraction also he has explained, and he has explained different colors. But that time, one more phenomena were known, that is simultaneous reflection and refraction of light, which he could not explain properly. He said that for simultaneous reflection and refraction, corpuscles behave as per their mood, and which was not justified. That means Newton's theory has certain drawbacks. First one is, it could not explain simultaneous reflection and refraction of light from the same medium. The next thing is, the speed of light in denser medium is less than that in rarer medium. This was afterwards proved by the scientist Foucault. He has experimentally measured speed of light in denser medium and rarer medium, and he found that speed of light in the rarer medium is greater than that of the denser medium. Now the next thing, is Newton's theory could not explain subsequent phenomena like interference, diffraction, polarization, etc. One more thing, that if light is in the form of particles, then as light is emitted in the form of particle, mass of the source of light should go on decreasing, and that is not happening. And that is one more drawback we can consider for the Newton's corpuscular theory. So this is about Newton's corpuscular nature of light, or this is regarding Newton's corpuscular theory of light. So here we have discussed its assumptions as well as drawbacks. 3 years later, from the Newton proposed his theory regarding particle nature of light, that is in 1668. A Dutch physicist, Huygens, proposed his theory regarding nature of light. Let us have a look on his assumptions regarding wave nature. What Huygens has considered? Huygens said that light is in the form of waves. What was his consideration? He said that it is a wave caused by vibrations of particles of the medium. All of you are familiar that waves are nothing but vibrations of particles in the medium, or we say that oscillations of particles. Now, when it is said to be wave, at the time he has considered that these are longitudinal waves. So according to Huygens, light is in the form of longitudinal waves. As already we have studied waves in 11th standard, so we are familiar with that. And we know that for the propagation of longitudinal waves, some medium is required. And as medium is required, and we know that from sun we get light on earth, and when light is traveling from sun to earth, it is traveling long distance, and if it is coming to this earth, naturally there might be some medium, and for that purpose he has considered that there is a hypothetical ether medium. Name to that medium given by him is ether medium. Hypothetical means what? It is the imaginary medium, or we say that medium is present which we are not able to see. Now, what are the properties of this medium? Properties of this medium are, it has zero density, perfect transparency, due to that we are not able to see that medium, and it is present everywhere including vacuum, because we used to say that in between sun and earth vacuum is present. So he has considered that ether medium is present in vacuum also. Now this is assumption of Huygens for wave, or for the propagation of wave, medium is required. Now what is next assumption? According to the phenomena known at that time, he could explain reflection, refraction, as well as formation of images by mirrors and lenses. Now this explanation we are going to study in detail in this chapter, so here we will not discuss that. Next, his assumption is that speed of light wave in denser medium is smaller than that in rarer medium. See here, in Newton's assumption, we have seen that Newton has said that speed of light in denser medium is greater than that in the rarer medium, and here Huygens stated exactly opposite to that. But afterwards, when speed of light is measured experimentally, it is observed that speed of light in denser medium is smaller than that in rarer medium. So we say that this assumption is correct. Next, the phenomena known at that time was different colors of light. So, for different colors of light, he said that it is due to different wavelengths of light. Waves are having different wavelengths, and these wavelengths are responsible for different colors. Then, afterwards, few more phenomena observed in 19th century, such as interference, diffraction, and these phenomena were also explained on the basis of wave nature of light. Now this is regarding Huygens assumptions and what can be explained on the basis of Huygens wave nature of light. We have seen plus points of Huygens wave nature. But at that time, one more well-known phenomena was there, that is rectilinear propagation of light. And this rectilinear propagation of light could not be explained on the basis of wave nature. Because we know that wave nature means it is a up and down vibration. And that Huygens could not explain properly rectilinear propagation of light. That is one of the drawback of Huygens wave nature at that time. Now with that, one more thing is there, that when we talk about ether medium, no evidences of existence of hypothetical ether medium were observed. Scientists have done number of experiments, but no one could detect the presence of ether medium, and scientists were clueless regarding ether medium. Next thing, it could not explain subsequent phenomena like polarization of light, Compton effect, photoelectric effect. Now these phenomena are observed in 19th century. So when he put forward his theory, at that time there were problems regarding these 2 points only, that rectilinear propagation and the ether medium. So we say that these are the two major drawbacks regarding Huygens wave theory. But after that, as polarization is the phenomena related to the waves, but still his theory could not explain polarization because polarization is not satisfied by longitudinal waves. And the main consideration of Huygens regarding light is longitudinal wave. So polarization could not be explained on the basis of wave nature. At the same time, Compton effect and photoelectric effect, these two effects were also not explained on the basis of wave nature of light. So this is about Huygens wave nature's assumptions and drawbacks. Let us compare between Newton's and Huygens concept regarding nature of light. Newton said that light is in the form of particle, that is Newton's corpuscular theory, and Huygens said that light is in the form of wave. This comparison we are doing so that we can keep in mind both these theories very easily, because comparison is the best tool to learn that particular thing, and we'll do this comparison on different points. First point of that is nature of light. According to Newton, nature of light is particle. What sort of particles are these? Tiny, hard, massless and elastic particles. Whereas according to Huygens, light is in the form of wave. Which wave? It is longitudinal wave, and he said that there is a presence of hypothetical ether medium for the propagation of longitudinal wave. Now next point of discussion is speed of light. According to Newton, speed of light in denser medium is greater than that the speed of light in rarer medium, whereas according to Huygens, speed of light in denser medium is less than that of speed of light in rarer medium. These 2 points are exactly opposite to each other. And afterwards, it was proved that speed of light in denser medium is less than that of speed of light in rarer medium. Next point of discussion is color. According to Newton, different colors of light are due to different sizes of corpuscles, whereas according to Huygens, different colors of light are due to different wavelengths of waves. Next, what Newton's theory could explain? Newton's theory could explain rectilinear propagation, reflection, refraction. These are the phenomena known at that time. And what Huygens explained? Huygens explained reflection, refraction, simultaneous reflection and refraction. This phenomena of simultaneous reflection and refraction could not be explained by Newton's theory. And newly observed phenomena as interference and diffraction were also explained by wave theory. What could not be explained by these? Newton could not explain simultaneous reflection and refraction, newly observed phenomena as interference, diffraction and polarization. Now what about Huygens theory? It could not explain polarization, Compton effect, photoelectric effect, etc. In fact, polarization is applicable for waves, but still, as consideration was wave, light is longitudinal wave. Polarization is not applicable to longitudinal wave. Now, what is drawback of these two theories? Drawback is the speed of light in denser medium is less than rarer medium. This is contradiction with the Newton's. According to Newton, he said that speed of light in denser medium is greater than that in the rarer medium. And for Huygens wave theory, there is a drawback, that is non-existence of ether medium. On these points, you can very easily compare Newton's corpuscular theory and Huygens wave theory, and you can keep in mind the points related to both these theories, and you can use it according to question. According to nature of light, up till now we have seen that Newton has said that nature of light is particle, whereas Huygens predicted nature of light is wave nature. And there was confusion between wave nature and particle nature. In fact, in 19th century, few phenomena related light were observed. Those are interference and diffraction. Now these phenomena supported wave nature of light. Huygens wave theory could explain these phenomena properly. Then came polarization. This phenomena is also applicable to waves, but Huygens wave theory could not explain polarization for light on the basis of longitudinal wave nature of light. Then after few years, it is observed Compton effect, photoelectric effect related to light. And these effects supported particle nature of light. So there was confusion regarding wave nature or particle nature. So there was confusion among scientists related to nature of the light. Sometimes it is felt that its nature is wave. Sometimes it was considered that nature is particle nature. Then in 1865, there was a scientist, James Clerk Maxwell, predicted light as a high frequency electromagnetic waves. And these are transverse waves. Earlier, Huygens was considered light as a longitudinal wave. Here, Maxwell has considered that these are transverse waves. What are transverse waves? We have studied that transverse waves in which electric and magnetic field in the wave vary periodically in space and time, and they are mutually perpendicular to each other, and as well as they are perpendicular to direction of propagation. Again, he said that these waves can travel through vacuum. No medium is required for propagation of light. Now this was observed in late 19th centuries. Again, in late 19th century, there was a scientist Hertz who verified existence of radio waves. And he has stated that the speed of radio waves is same as that of the visible light. Now what are radio waves? Radio waves are nothing but electromagnetic waves. So there was a support for Maxwell's consideration that light can be transverse waves. Then in the early 20th century, Max Planck and Einstein hypothesized light as a concentrated packets of energy. Einstein proposed the special theory of relativity, and he ruled out the existence of necessity of ether medium. And he said that light is nothing but the packets of energy, and name to that is given as a quanta or photons. Now if it is a packet of energy, then how much is the energy of it? Its energy is given by E is equal to h into nu, where h is Planck's constant and nu is the frequency of the wave. Now here he is talking about packet as well as he is talking about frequency, isn't it? And from here there came in existence the new branch of physics, that is quantum mechanics. On basis of all these things, in early 20th century, it was accepted that light has dual nature and it exhibits particle as well as wave nature under different situations. And these particles of light are said to be photons. So, well accepted today's nature of light is dual nature of light. Once nature of light is considered as a dual nature, and in that light, when we consider as a wave, it is considered as transverse waves or electromagnetic waves. Actually, we have studied electromagnetic waves in 11th standard. So we know what is electromagnetic wave. In brief, we'll revise electromagnetic waves, and here now I'll take x-axis, y-axis and z-axis here, because electromagnetic wave is a time and space wave. So here in space coordinates, we are considering the x-axis is showing direction of propagation of wave. Now here we have a red color wave, and this is indicating electric field associated with electromagnetic wave with its amplitude E0. With its amplitude E0. Then this electromagnetic wave, this electric field is perpendicular to y, or its vibrations are along y-axis, and it is present in xy plane. Vibrating in along y-axis, and it is in xy plane. Now, with this, there is associated magnetic field also, and this magnetic field is shown in green color, and it has its amplitude B0. This magnetic field is vibrating in along it is vibrating perpendicular to x-axis, and it is vibrating along z-axis. Both these waves, or both these fields which are represented by waves as an electric field and magnetic field, both are perpendicular to x direction, which is the direction of propagation. Now, once we know this, we'll see properties of electromagnetic waves. And what is electromagnetic wave? Light is an electromagnetic wave with tiny oscillating electric and magnetic field. See, these electric and magnetic field which we talk about, they are very small fields. That is in case of light. Then it has transverse nature. The direction of electric field and magnetic field, both these are perpendicular to each other, as well as they are perpendicular to direction of propagation of wave. The speed of electromagnetic wave in the medium is given by V, and it depends on refractive index of medium, which is represented by N. This which depends on permittivity and permeability of medium, that is electric and magnetic properties of the medium. See, permittivity and permeability, these are the electric and magnetic properties of medium. We have studied this in electrostatics and magnetism respectively. And this refractive index is depending on these two quantities of medium in which the wave travel, and it is independent of the amplitude of variation. Whatever is this E0 and B0, that will not contribute anything for the value of N. Now, how this value of N is given by? It is given by formula N is equal to C upon V, where C is speed of light in vacuum, whereas V is speed of light in that medium. And this C is given by 1 upon under root epsilon 0 mu 0, where epsilon 0 and mu 0 are permittivity and permeability of vacuum. Now what is this N? This N is absolute refractive index of the medium, and this is greater than 1. It is greater than 1. Why? Because we know that speed of light in vacuum is the maximum speed. No other object can travel with the speed more than that the speed of light in vacuum. And as this is the maximum speed in any other medium, its speed is less than that of the C. Due to that, the refractive index, absolute refractive index is greater than 1. And this V is given by 1 upon under root epsilon 0 epsilon r mu 0 mu r. We know what is epsilon 0 mu 0. Epsilon r and mu r are relative permittivity and permeability of the medium. And from this also you can see that value of V is less than that of the C. And on this basis, again we can say that speed of light in rarer medium is greater than that of the denser medium, because vacuum is said to be rarer medium with respect to all other medium. And due to that, Huygens' assumption regarding speed of light in rarer medium is greater than denser medium is found to be correct, even with consideration that light is the transverse wave. In 11th standard, we have studied that electromagnetic waves have wide range. As their range is wide, they are divided into different categories such as gamma rays, X-rays, ultraviolet rays, visible, infrared, microwave, radio wave, etc. Now, while talking about these electromagnetic waves, we can see here the crowding of that wave is observed initially, then it is becoming wider and wider. Now, what this indicates? Within this region where there is a crowding, wavelength is less. And the region where it is getting separated, more and more separated from each other, at that time wavelength is more. Means as we are moving from left to right here, so wavelength is increasing. So for wave, wavelength is increasing, and here you can see that wavelength values are given that for gamma rays it is in the range of minus 10 raised to 15, minus 10 raised to 12, whereas X-rays are in the range of 10 raised to minus 9, and we are moving from 10 raised to minus up to 10 raised to plus range. So wavelength is changing from 10 raised to minus 15 meters to 10 raised to 6 meters. That is the wide range of wavelength is observed. Now as wavelength is increasing, what about frequency? Naturally frequency is decreasing, and here we can find that here frequency is 10 raised to 24, 10 raised to 21, and it goes on decreasing up to 10 raised to 3 Hertz. Now, our main aim is to focus on visible region, because we are dealing with light. So we'll focus on visible region, and here you can see that visible region, this is ultraviolet spectrum and this is visible. We'll focus on this. Visible region is having wavelength from 400 nanometer up to 700 nanometer. This even you can consider in terms of angstrom unit, which we use regularly, that is 4000 angstrom unit to 7000 angstrom unit. Angstrom units conversion is 10 raised to minus 10 meters, and nanometers conversion is 10 raised to minus 9 meters. So visible range is within this region, and here you can find out that the 400 nanometer is in the violet region, whereas 700 nanometer is in the red region. Now when we talk about these colors, for us what is important? Refractive index of the medium. And the refractive index of the medium depends on wavelength. If wavelength is different, refractive index is different. And as refractive index is different for different wavelength, then can we say that for the same angle of incidence, angle of refraction is different for different colors or not? What do you think about it? See, in 11th standard, we have studied dispersion. So, there we have observed this, and here you can see that this is white light. See, in diagram, since background is white, so I have taken it black. And when it is entering into the another medium, at the time it is getting separated from each other. Splitting of colors is there. And the angle of refraction is angle made by that color with the normal. Here you can see that angle of refraction for violet color is less than that of the red color. Means angle of diffraction, angle of refraction are different for different colors, even though its angle of incidence is same. And due to this, colors in white light get separated when passed through the transparent medium. And this is the reason for formation of spectrum and rainbow. So what we say, as different wavelengths have different refractive index in the medium, or for the same angle of incidence, angle of refraction for different colors is different. Due to that, spectrum or rainbows are formed. Now here again your refractive index is playing main role regarding the different colors. So this is about light as a transverse wave. In this we have discussed corpuscular nature of light, we have discussed longitudinal wave nature of light, as well as dual nature of light, and in briefly light as an electromagnetic wave or the transverse nature of light. So here we have discussed everything related to nature of light. We are studying nature of light. Now we'll see what are studies of light. In studies of light, now we are studying wave optics. Now what is wave optics? Wave optics is a branch of physics or branch of optics specifically, I'll say, which uses wave nature of light to explain optical phenomena. With the consideration of wave nature, when phenomena are explained, it is known as wave optics. In 11th standard, we have studied ray optics. What is ray optics? Ray optics is also known as geometric optics, and it is the study of optical phenomena under the assumption that light travels in straight line as ray that we have studied. Then here, if I say that in ray optics we have studied the phenomena, reflection studied, refraction we have studied, shadow we have studied, all these things we have studied with the consideration that light travels in a straight line. Then what about rectilinear propagation of light when we consider it as a wave? The reason that rectilinear propagation of light is explained on the basis of wave because here we say that the wavelength of light is very small. And due to that, when we talk about geometric optics or ray optics, this geometric optic works in case of shadow, reflection, refraction because wavelength of light is much smaller than the reflecting or refracting surfaces as well as the shadow causing objects. And due to the smaller wavelength, we can consider this ray optics or geometric optics also for optical phenomena as reflection and refraction. In today's video, we have studied different natures of light, and here I'm giving you list of the questions which are based on today's topic, that is nature of light. If you prepare these questions properly, you can answer any question to be asked on this article in your board exam. Thank you for watching. See you soon on next video.